Hey Alan, how's it going?
Hey, it's going well. Hey, Rajiv.
It's been a while since we actually sat down and talked, but really nice to catch up and spend a few minutes talking about some cool AI stuff here.
It's always good to get back together. Always good to talk. And I'm always, obviously, always interested in artificial intelligence, machine learning, anything along those lines.
Yeah, absolutely. That's definitely our main topic of conversation here. I know you and I have worked together on other web projects, mobile projects, but our audience definitely, from a 2M2X digital transformation perspective, I really want to get them more up to speed on basically the kind of decisions and considerations that you have to take into account when you're dealing with AI. So I look forward to getting into that. So why don't we start off, Alan, and share a little bit of background about how you got into AI, what your background with AI is?
Yeah. So I've been a programmer for about 16 years, anywhere between, when it started out, very basic stuff, WordPress and stuff like that. And the last few companies I've been part of for the last, I don't know, 8 years, something like that. I've been either director of engineering, CTO, some sort of leadership role. And the last several that I've been part of have all been very metric driven, analytic driven companies. The one that I've learned sort of the most about AI in was an advertising agency, and we analyzed social media profiles basically to build a few things. One, sort of predictive analysis around social media, and two, to build a search engine of social media influencers for advertisers to go to and sponsor content for. The reason that took a lot of AI was when advertisers came to us, they said, well, we want to know about their audience. We want to know, the influencer's audience. We want to know about the topics that they talk about. We want to know sort of, I like this influencer, find me 15 others that are similar to that. And so there was a lot of techniques that we used for a lot of different metrics that we had. And I was a little bit of a newbie to AI. I had done AI for a few years on and off, more statistical analysis, but maybe with a little bit more than just plain old statistics. And I got thrown into that one, and I was like, whoa, okay, we got to learn a lot more here than just like non-linear regression and just regression formulas or any of those sorts of things. So we did a lot of regression stuff, a lot of traditional statistical modeling and stuff like that, but a lot of deep learning, natural language processing, that sort of stuff, all of the big kind of buzzwords that are fun nowadays. So I got a large understanding of all of the different pieces that make up something like that. And then, with you, we've worked on some subsequent AI projects for other companies that have large amounts of data and they want it summarized in some sort of interesting way. So you can do a lot with AI. There's lots and lots and lots of different things. And it's a huge amount of data to make something really, really work and really effective. So the more data you can gather, the better.
Yeah,
So that's
absolutely.
kind of the history, yeah.
Yeah, that's a great point to drill down on a little bit. So there's so many different applications of AI, and for the layperson, everything is AI. Chatbots. There's
Mhm.
natural language processing. There's motion sensing. There's so many different things. So can you break it down for us a little bit? Like, what are the different major groups of AI?
Yeah, and more than just that, a lot of AI projects, there's kind of two that I've been part of where someone will come in and say, well, we don't really know, we have a lot of data and we don't know what we want to do with it, but we want something with AI or statistical modeling. And then there's another side of it, which is someone coming in, a customer coming in or whoever, and saying, I have this problem to solve, and we don't know if we have the data, we don't know how to get the data. And so those are kind of two opposite extremes. The way that I look at this and the way that I kind of solve these problems is every AI question has to start with what is the business goal that you're trying to solve, or what is the feature you're trying to build. After that, and there's loads of those different things. So it could be we have house prices in a certain area, and given X amount of metrics about these houses, location, what neighborhood they're in, maybe the sale prices of other houses around them, square footage, all this stuff. This is the sort of classic example. Bring all of that information into one place run a bunch of different AI predictive analysis on that, where you say like, okay, well, we could use tons of different algorithms, for lack of a better phrase. We could use lots of different algorithms to come up with this, and you just run through a lot of them and see which one kind of works the best. More or less going into a problem, you have an idea. So as an example, something with vision is usually a completely different tool set or a different way of thinking about the problem than something with natural language processing. And that's something different than a little bit more statistical modeling or numerical values. So if you're trying to predict prices, you're going to be using a different set of AI algorithms than if you're going to be using vision. It's not always the case, but you can mostly divide it into those three areas. And then the other thing to think about is that AI is usually only good at predicting things. It's good at a lot of things, but it's best at, I'll say this, it's best at predictive analysis and sort of taking data that you have and maybe clustering it or categorizing it. Those are kind of the areas that you can think about. So a chatbot, something that you brought up, a chatbot isn't, most chatbots out there aren't systems that know how language necessarily works. We have a few exceptions with GPT-3. That one kind of learned language after a while. But most chatbots are kind of rudimentary. And what they do is they just predict, given a set of possible options of things to say, like, you know, the user said this to me, I have 8,000 different options of replies, predict which one is the most likely that the user will continue to engage, or that's the most likely response to that. And so it's a predictive system. It's not sort of understanding what the language model is and then writing its own language. It's more of a, here's your choices, select from them. Again, other examples or exceptions to that are stuff like GPT-3, but those are not mainstream examples. Those are weird, not weird, but those are grand experiments, I think, that really push the industry forward, but they are not the types of things that small to medium-sized businesses would be deploying on their own. So, yeah.
You're saying it's not going to pass the Turing test anytime soon?
I'm not sure about that. I've been curious about that over the last few years, and I've played around with some GPT-3 stuff. And for short conversations, it does surprisingly well, but after a little while, it starts to meander and not make sense. So I think a true AI that could pass the Turing test reliably and consistently is still a long ways away, but we're inching closer, I think, every year with every new innovation.
Yeah, that's good to know. So that's good. That's a good categorization to start with. Like, so the data science related applications, vision related applications, natural language, and then predictive chatbots kind of thing. And of course, the effort and planning involved for each one is different because the business objectives are different, and the state of the art is different. So from a CIO, CTO perspective, right? I mean, of a, let's say, mid-sized company who has never implemented AI, what would a CTO, CIO need to know? Like today, there's like some stuff that is relatively well-defined and baked that I can implement relatively quickly, versus stuff that, hey, I need like 24 PhDs in order to even think about this thing.
So I would say, for the most part, the process for building something that is AI versus just a statistical analysis of stuff is not very different in terms of the way that you think about the process. The results are very different, but the way you think about the process is very similar. So often the way that I've done this is almost entirely the way that I've done this, that someone will present, CEO, CTO, whoever will present, hey, we need this feature for our customers. Sometimes it would be, so some of the things that I did at my last startup was we wanted to predict whether a social media account was a bot or an actual person. And so we started with the sort of regular statistical modeling around that. So it's like, well, can we start to cluster things and group? If they post once a week, then maybe they're in this group or maybe they're in that group. And we we don't make those arbitrary decisions. We kind of analyze the data and say, okay, here's how we group them. But it's very from a statistical perspective, not from an AI perspective. And we did that for our first few rounds of kind of exploring the data. And we basically made some naive models. So they are models that would make correlations when there may not be any of those correlations that actually exist. But they got us to a certain point, and then we were, hitting the accuracy limit on that one, which I want to say was something around, like, it wasn't very good. It was, we had to predict human or non-human, and we were only hitting something like a 70% accuracy, which is terrible. But you kind of have to do that to understand your data and to understand what you're working on. And then at that point, we turned to more of a deep learning process. And that was when I had to learn a lot more. But the technique of thinking, what are the properties that tell us the most amount of information about what we're trying to predict? You still have to think through that, because with AI, your first instinct is to just feed it all of the data that you have. And most likely 99% of your data isn't going to give you, isn't the data that you need to make your predictions. There are ways of figuring out what data is best for your predictions, and that's part of the analysis process. I think that there's a thing called principal components analysis and some other things like that kind of are good places to start to figure out how your data kind of fits into stuff. There's a few other ones that tell you after you've trained a model the first time, you can actually ask it which properties contributed to the model's accuracy the most. But essentially, the first round of AI stuff, you're kind of shooting in the dark a little bit. You know a little bit about your statistics and how your data works. You kind of are making some assumptions. You feed that into a model, and you more or less, depending on the model, right? Like natural language takes a different model than vision, and that takes a different model than numerical values. But you feed that in, and you just kind of see what your accuracy is, and then you look at which properties contributed most to that accuracy. And usually at that point, you then have to go back and get more data. It is a constant game of getting more and more and more data. But if you're just starting out and you think that you have an AI problem on your hands, I kind of think don't skip to AI right away. Try to go through this traditional statistical modeling method. And if you can get somewhere with that, that'll give you a lot of really good understanding over your data as a whole. Some tools that you can use, the ones that I've probably used the most are for that sort of traditional data modeling. I've used scikit-learn. That's, I think, the go-to one. There's new AI tools popping up every day, so it's almost impossible to keep up to date with all of them. But scikit-learn has been around for a long time, and it's really solid, used in a lot of different things. But it's a little bit more statistical modeling. And then after that, the new deep learning library that I've been using a lot has been PyTorch. I was using TensorFlow for a while, but I've kind of mostly moved over to PyTorch at this point. It's a little easier to work with. But I would say start with your statistical modeling, and then kind of move on from there to figure out what the problem is that you're really trying to solve.
Gotcha. So kind of zooming up to where CIOs and CTOs for use cases for them to consider using AI.
Yeah, so I haven't been involved in any projects beyond engineering feature projects. So we need to show, usually my projects that I've been involved in are we need to show an end user some sort of summary of their data and then make predictions on that data. A lot of it has been like the success of a campaign. So given a certain image and maybe text and some hash signs or hashtags, like what do you predict the success rates of that campaign are, given that X amount of people might consume it and that sort of stuff. So that's kind of where I've come from. But there's some other things that you can apply AI to also, like I've heard people applying it to making decisions on not just which features should be implemented, but like which products they should focus on the most. So, every company, most tech companies nowadays tend to have more than one product. And you can actually use, like, if you want to check user growth, for example, you want to look at user growth and you want to see, like, well, what is the predictive analysis on user growth given a lot of different properties? That's something that I've heard of people doing outside of engineering. So I would group it into two things. It's sort of, how do you want to analyze your company and what's the predictive metric that you're looking for there? And then the other side would be, what features do you need to build into your technology that your users want? Those would kind of be the two extremes.
Perfect. Yeah, that's very helpful. So predictive things related to user actions, correlated with maybe some demographics or past actions would be one way to use it. Maybe also potential correlation between product features and other attributes of the user. Is that what you're thinking would be the initial piece that would help
Yeah.
CIOs get the first pass into AI?
Yeah, and one of the things that I've worked on that kind of is what you're talking about is, so at my last startup, we did a lot of analysis of individual social media accounts, but that was to understand that account. We still needed to then understand our user and what our user wanted. So when an advertiser came onto our system, we could give them, like, hey, given this social media influencer, give me the closest 15 in similarities to that one. We could do that, but not everyone wanted that. So we started implementing a secondary layer on our users, which was to kind of generate a demographic understanding of them. So a company that is advertising, I don't know, trucks is going to be a vastly different marketing campaign than a company that's going to be advertising, I don't know, loads of other things, right? And so you can do it both ways. You can understand the data that you have in your system and how to give that to your user, and you can also use AI to understand the users themselves and say, well, this model is useful for 80% of our users, but this other 20%, we have to build a secondary model because we're not showing a lot of engagement. And again, a lot of that can come from just normal statistical analysis of saying, yeah, we see a segment that's not engaging well with our product. But then after that, to build those features that you want, you can analyze users with artificial intelligence and generate that sort of stuff.
Right.
I mean, that's how suggested search results work, right? So, Google or YouTube or whoever understands you, Netflix understands you, and that's how they recommend, here's the next video that we recommend for you.
Yeah, AI-enabled recommendation engine, like, hey, people who bought this product may also be interested in X and that kind of thing. Yeah.
Exactly.
Those are powerful. Yeah, very, very well-defined niche, but also one that's well understood application perspective. That's very helpful. Thanks. So you were halfway through kind of talking about the process of, the kind of life cycle of the dev process. And also I'd like to kind of talk a little bit about how does this engage with Agile, because Agile is like 2-week sprints and that kind of thing versus Waterfall. And for AI, does it have some kind of combination of both approaches, or does one better fit with the other? I think it'd be great for our listeners to know about that.
Yeah, absolutely. In my experience, for the most part, I'm sure somewhere this can work, but in my experience, the waterfall methodology for AI, 199 times out of 100 doesn't work. AI by its nature is kind of always an experiment. Same with statistics. It's always an experiment. You look at your data, you analyze it a certain way. Your first model is not going to be your best model. It's going to be a starting point. And a lot of times you'll build first models so that you can sort of secondary classify things, or classify things so that you can build a second model. I'll come back into sort of the life cycle of AI in a second, but I'll give you an example of what I was just talking about. One of my favorite companies, Tesla, they are clearly some of the best, like, in AI right now. They, over the years with autopilot, basically built out some rudimentary, kind of naive vision models. And those vision models were at first built based around like a 2D sphere around the car. And so they just wanted to know what was around the car. They didn't really care where exactly it was, like how close or anything like that. They just wanted to kind of identify what things were, because that's the first step. If you don't know what a thing is, you have no perspective on how close or how far away it is, because you don't know the size of it. So they just wanted to know what was around the car. So stop signs, other cars, bikes, pedestrians, that sort of thing. They classified those in sort of 2 dimensions. And then that allowed them to query their fleet and say, give me more examples. The AI trainers themselves would say, give me more examples of dogs walking across the street, or give me more examples of pedestrians. And those naive models, they aren't 100% accurate. They're more just like an alpha build, an alpha sort of model. But it would be able to then say, I have a 70% certainty that this was a dog walking across the street. And then the AI researcher could say, well, no, that was actually a goose, or whatever, or that was a pothole that was just in the right shape and it looked like a shadow, or, whatever it is. They could then refine those models. So building your first model can kind of help you filter your data almost, so that you can then refine your data to build your second model. And then your second model helps you refine your data to build your third model, and so on. And that kind of becomes like a cycle. At a certain point, there's a few things that happen. Like I said, you build your first model, you look at your data, you refine your data based on what your model is predicting. You go back again, build your second model, and so on. At a certain point, you usually run into that you don't have enough data in one area. One of the things that we ran into at my last startup was we were trying to categorize, like I said, social media influencers and their profiles. And we had we were trying to categorize them in maybe like 20 different categories. And we had a lot in one category. And then in a few categories, we only had a few examples. And so we were like, well, let's see how the machine learning system can learn on this stuff. And it turns out that it learned the thing with a lot of examples really well. And the thing with like only a few hundred thousand examples, it basically couldn't learn it at all. And so then for the next 6 months, our goal wasn't to write code. It wasn't to build a better model. It was go collect data, right? It was collect data from this category that we need more data for. And so you get into that cycle where it's, I've built a model, we've taken it to its accuracy limit, we've used the model to analyze our data, to filter our data, to categorize our data more. We've done that again and again and again and again, and we've hit our limits. We need more data now. And at that point, that's a hard thing to shift in people's minds, because you think that you can just refine things forever. Because you're used to, with programming, traditional programming, you click a button and it works, and it's very like one-to-one. We know that the system works. With AI, you have to almost embrace this idea that you have to, going back to your question, you have to be agile. You have to know that your first several versions aren't going to work, and you almost have to go in going, we know by the time we reach a certain version that we are going to find deficiencies in our data, and that we're going to have to solve that. But you kind of have to go in blind almost and say, like, we don't know what our problems are, but we'll get to a point where we can analyze them and figure out what our problems are.
So Alan, let me ask a question about that. I'm not an AI expert on this, but do you find that, for example, user segmentation, that certain, as you said, categories exist, and do you have different models then? So like this segment has this model and this other segment has a different model, or do you generally build your model generic?
That's a really good question. And I think that there are some generic models for classification and clustering and categorizing of people. But really your model has to stem from the data that you've collected. So as an example of this, our demographics model that we were building at my previous startup, the demographics model for YouTube was vastly different than the demographics model for Twitter, right? So, because Twitter was just all text, so we had to do like natural language processing on that sort of stuff. and we could analyze a whole bunch of tweets and kind of really understand that person just from the tweets that they put out. Whereas YouTube, it was all video stuff, and we couldn't analyze that individual as well, because that would take video analysis and that sort of stuff. And you could analyze the closed caption tracks and stuff like that, which we tried to do. It just wasn't as good. It was a completely different thing. A tweet is a different thing than a 10-minute conversation. And so even though they were generating the same output in the end, those were two different models. They were using the same techniques. They were using the same sort of off-the-shelf type of algorithms, I guess. But the input and the way that they were sort of pre-processed and the way that the data got into the system was completely different. So yeah, we had to treat them like two separate models. I guess my point is, your model stems from your data. There are sort of off-the-shelf ones that you can use, but a lot of it stems from your data. And there's a step that a lot of people don't talk about, because it's not the cool sort of stuff of AI, but it actually is a really important step, which is called pre-processing, which is, everyone knows what that word means, but it is the step of taking your raw data and converting it into an intermediate data type that your model can understand. So for example, machine learning models can't really understand words directly. They understand sort of a few different things. They'll either understand, you have to turn them into numbers somehow. There's a few different ways of doing that. There's a way where basically you take every word in the dictionary and you give it a certain number, right? I think that's called the bag of words model. And then there's some more intelligence ones where basically someone's taken, usually Facebook or one of those companies has taken Wikipedia most of the time and analyzed in a d-dimensional graph kind of where every word sits in its relation to other words. So you might get something like king and ruler and monarch and all of these things. You might get those tightly clustered together, and you might get other words tightly clustered together. And that way everything has sort of a numerical value in d-dimensional space. You can think of it as a three-dimensional graph where each axis is a different property of it. So there's lots of ways of doing that, but that's kind of part of the pre-processing stage, where you take your raw data and convert it into an intermediate format for the actual machine learning stuff. And I would say that part is probably some of the least understood part. When I've worked on machine learning, people didn't understand that part as well as the actual building of the model. And I would almost say that part is sometimes more important than the actual model you pick, because if you don't pre-process your data correctly, it doesn't matter what model you apply to it. Your data is kind of garbage in, garbage out style. But if you pick the wrong model after you've pre-processed it correctly, your model will tell you its accuracy. So you can go and swap in a different model and change that out and try a bunch of different things if it's pre-processed correctly. So
that makes sense. That's very helpful. Yeah. So kind of we got into the developer level there, but just to round that out before we zoom back out, from a developer perspective, right? So we talked about the pre-processing, we talked about picking the right model, picking the right algorithm, and then the ongoing refinement of the model, and then of course running into potential issues related to the data not being sufficient in a certain category or whatever, and then going after data, and then ongoing actual iterations to keep working and improving your quality of the model. But from and that's very different, right? From a development perspective, if I'm a web developer, mobile developer, even a database developer of any kind, this is a very different process than what you would normally do. I guess it is not that dissimilar from data science, so that would be the closest discipline for this. But how much of a shift is it from going to data science related stuff? Well, let's start from web to data science and then data science to AI.
Yeah. So I would say a major shift. This has been one of the big challenges that I've come across when talking with companies in the early stages of wanting to implement AI, is that a lot of times they may have built a lot of different products. They've built web apps, they've built their APIs, you said, build their database out. And the developers understand that, and they understand how to test that, right? So they understand you send your API this data, you do a get on that API, it returns you the same data. Maybe it's got some virtual properties, maybe it's done some transformations on it, but you mostly know it's a input and then a certain set of steps and then an output, and it's predictable every time. And I come back to this example, that when you press the button on an app, it should do a specific thing every single time. And shifting that mindset over to one of, honestly, a lot of unpredictability and a lot of unknowability has been, at least for me and the teams that I've worked with, the biggest challenge. And it's also been the hardest thing to describe to customers and people I've worked with is, they'll usually say, what's the due date on this thing? And with traditional development, you can more or less predict that. Agile is kind of about due dates are a little bit flexible, but it's more about the process. But you still always have to have a specific due date. With machine learning stuff, the amount of times that I've gone into a meeting and said, I don't know. I don't know about this. I don't know the due date. I don't know. All I know is the process. And until I get to the next step, I can't tell you the step after that. The amount of times I've done that has been innumerable. And it's on one hand kind of frustrating because, I think as developers, we love certainty. That's part of the reason that we have this job is most other jobs are in some ways uncertain. Development is very certain. And then shifting to AI, it's you get all of that uncertainty back. And it's really hard to get your head wrapped around, like, when is this going to be due? When is this, what are the next 5 steps? Because you really only know the next 1 step at any given time, maybe the next 2 or 3. But until you do those, you can't know the ones after that because each step tells you sort of information about the next one. That's to put it in generalizations. Certain models have certain known steps. Like I was talking about the pre-processing stuff, if you're doing natural language processing, you have to take your words and convert them into word vectors or whatever. You need to pre-process them. So that step's going to happen. But you don't necessarily know if the data that you have in the database predicts what you're trying to predict until you do your first model. You can do some statistical analysis, but you can't do all of it. So to me, at least, it was a major shift from something that was very, very certain to something that was like always a moving target, always in flux, always very uncertain.
Yeah, no, this was very helpful. That's exactly what I was trying to get out there, because from both from a leader's perspective and for developers that are watching or listening, the mindset shift is a big deal, because you're used to working with deadlines, estimates, budgets, and all of that. But with certain applications of AI that are more kind of learning type AI, you're going to be in the unknown on some of that, and it's good to go in with those expectations. And that's why I wanted to make sure that you actually did walk us through kind of the different steps and the unknowns in each step. It's not just an unknown with one step, but it's an unknown at every step that you have to work through. So that's very helpful. Yeah. We're coming up on time here, but I want to make sure I get 2 more kind of conversations going. One, just kind of share, you shared a little bit about your past, kind of talk about where you're going next personally with AI and things that you're interested in learning about, you're excited about coming up in the future, and then any resources that you would recommend.
Yeah, absolutely. Well, I'm always interested in just emerging AI stuff in general. Unfortunately, some of the projects I'm working on right now are more statistical analysis of things and more traditional, not unfortunately, but more traditional programming. But anytime that I can get into AI, I try to do that. Projects that I'm interested in, I'm not even that sure what projects. The one that I'm most interested in is just self-driving cars and seeing where that goes in the future, as well as I'm really curious about where we're going to go with natural language processing and stuff like GPT-3. I'm really curious. I know that was more of an experiment than something practical, but seeing where weird experiments like that or interesting experiments like that, where those go, that's kind of where I'm interested. And then in terms of resources, I tend to come at this from a developer perspective, but I like being a practical developer about these things. If you know every single thing about AI, how it works, like, at the low level, but you can't implement it in a project, then it can't be implemented. So I like coming at it from a, what's the practical approach for these things? And the most practical course, I guess I would say, that I've gone through to learn AI has been one called fast.ai. It's a program that's built off of, or it's a course that's built off of PyTorch and another library called FastAI. But it can get you in really quickly. It can teach you a lot of the broad concepts of AI. And within the first week, you can be building your own classifier and some other things like that. I actually kind of also think that the FastAI library can be probably brought into production for some things. I probably would always go with PyTorch in the end. But yeah, that would probably be the area that I would recommend the most. And if you really want to, if you want to just have some like nice AI conversations and vlogs and whatnot on all the time behind you that you're just listening to, there's a YouTube channel called SentDeck or SentDex, SentDex. And he's a fascinating guy. He builds a lot of AI models sort of in real time over a few hours as you watch. One of my favorites was a series that he did about building a self-driving car in Grand Theft Auto 5, which was fantastic. And it was great to see it. Specifically, I loved this is going back to the points earlier, that he drove the car in Grand Theft Auto 5 as part of his training stuff. He put that training back into the model, and the car drove like a lunatic. And it's like, well, of course it did, because that's the training data he gave it. So I loved seeing that, like, yeah, it did exactly what you trained it to do. So that sort of stuff was fun. So those are the resources I would recommend.
That's awesome. That's very helpful.
Yeah.
Yeah, if you think of anything else, let me know, and I'll put in our links when I publish this episode. But this was absolutely fantastic. I really loved how we covered the top level for C levels, how we touched on the developer level and kind of connected the dots on the process there. I think it'll be a great orientation for anybody considering AI and the different applications there to kind of get a primer on how to approach some of these different applications. So thank you very much for your time, Alan. Look forward to continuing to chug along with some of our projects here. As always, a pleasure talking to you.
Thank you very much, Rajit. Pleasure talking with you too.
Have a great one, sir. Take care.